Hello everyone, my name is Noor. I'm going to be a tutor for the summer 2021 program at Level 10 Library Tutoring Program. I'm going to be starting with Algebra 1. I will be going over linear algebra today in this video specifically, and it will also include some take-home questions which you guys can solve. In addition to that, I just want to go over the topics that we will be covering today in this video, which will be linear equations, absolute value, inequalities, piecewise functions, and writing linear equations. And keep in mind that the graphing we're going to be learning is going to be graphing linear equations, graphing absolute value equations, graphing inequalities, and graphing piecewise functions. And another thing we'll be going over in regards to graphing will be how to figure out a graph. Given a graph, how to figure out an equation from that graph, whether it's a linear graph, whether it's absolute value graph, it's piecewise function graph, it's a inequality graph. And I will be going over these 6 topics today. I will be going over graphing at the end because we are going to link those to all the topics that we have here. So let's start with functions and their graphs first. Okay, so I'm going to start with function and the graph. So the basic thing about linear function is, what does linear mean? Linear means anything that's straight. It comes from the word line. And a line could be like this, it could be like that, it could be like this. Or that we could have 2 lines that are like this. So we can have any type of line going any direction with any type of rate of change. Now, what is the rate of change? Every line has a rate of change. Rate of change is anything that tells us by how much something is increasing and by how much something is decreasing. I mean, we don't know how long this line is going to be. We don't know how long this line is going to be. But what we can know is we can put this line on a graph like this, and then we put the same line on a graph. So what we can do, we can approximate the rate of change that this line is taking. This would be the rate of change. The reason I drew it like this is to show you. So it's 2 up and it's 2 right. So you can say 2 units. You can use that. You can say 2 units. It's going 2 units up and 2 units to the right. And when you come, you're looking at the other side of the x-axis, which is this side. It's going 2 units down and 2 units to the left. Now we're going to look at an example of a linear function, and then we're going to look at the graph of that, and then we're going to dissect what is a linear function made out of. For example, a linear function is made out of 3 things. First, it's m, which is the slope. Okay. The second is the y-intercept, which could be anything, which is denoted as b. The third is the x-intercept, which you have to find. It's not given to you, but the way you find it is that you have this equation, y equals mx plus b. This is the slope-intercept equation. Okay. This is the slope. This is the y-intercept. How you find the x-intercept is you have to make y 0. So you make y 0, and then you solve for x. Solving for x will give you x equals negative b over m. That's how you get the x-intercept. X-intercept is basically, let me draw for you guys. X-intercept is anything where y is 0. So let's look at this line. This is a straight line. We don't know what its equation is. We just know that its equation will look something like this. So looking at this, we're going to go over a few things for this line. The b we know is a y-intercept, and you know the y-intercept is when x is 0, and x-intercept is when all y's are 0. So so where do you think on this graph y is 0 in the coordinate? Here. We can say this is 2. So we can say that this is intercept. Now this is an x-intercept because the y at here is 0. So the coordinate here is 2 comma 0. And then looking at the y-intercept, you could say it's here because there's no x for that y. The x is 0 here. The y you could say is maybe negative 2. Now, you can say that what if there's two places on the graph or on the line where the x-intercept is 0? Then the x value is 0, then does that mean that the line has 2 y-intercepts? Yeah, that is true. It could have 2, it could have 3. It depends on the degree of the equation you're dealing with. But since in this case we are dealing with only linear equations, we are only going to talk about first degree, which is x to the power of 1. And then in the next video, we're going to be talking about quadratic, which is second degree, which is x to the power of 2. Okay, so moving on. Moving on to the next thing is the example that I wanted to share with you guys about functions and their graphs. So the first example, let's say we have a linear equation which is equal to y equals x plus 5. Okay, y equals x plus 5. So look at this equation for a minute. What are the things that are given to you? What are the things that you have to find? And what is the thing that you have to do? So everything is pretty much given to you here. You have 5, which is the y-intercept. You have the whole equation. You are also given the slope, which is 1 in this case. So you're given the slope and you're given the y-intercept. And those are the only things that you need to really graph a linear equation. And remember, this is a review video, so I'm just going over the main and the core concepts that you guys will be needing for your exams and for the regions. And if you guys have any questions about more details that you want to know, or you're still confused on some concepts, you can always email me, or you can always email the tutoring program, or you can talk to the library and reach out to them. So let's move on. Y equals 1x plus 5. So how will we go about graphing this? Well, first we will need to draw a coordinate plane, and then you can put numbers on it, roughly. So let's make this -5, make this 5. I will make this 10, then I will make this 5. I'll make this 5, make this 10. It's a rough graph. Okay. Next, let's see. So we know Rm is 1. So what does that mean? That means that we're going up 1 and we're going to the right 1. Right? Because this basically change in y2, y1 over x2 minus x1. It's equal m. So our y-intercept is 5. So let me just do this in black. I'll do it in orange. It's 5. So that means our y is 5. So we're gonna okay. So that's good to go. Next thing we're going to do, we're gonna go up 1. Then we'll go to the right. That's our first coordinate. Go up 1, go to the right. That's our first. Go up 1, go to the right. So I think 3 points are more than enough. More than enough that you will be needing to graph an equation, linear. Then the same thing you're going to be doing on the opposite way. So you're going to go down 1. You're going to go to the left. Go down 1, go to the left. Go down 1, go to the left. Now you have 6 points. 3, 4, 5, 6. You have 7 points, including the y-intercept. Now you can easily draw a line. Let me just highlight the points for you. Just here. Now we're going to draw a line. Okay, so that looks like a straight line, and it is a straight line, even though it's not passing through all the points. But remember, a line is never perfect, but it is a straight line. So that's your line. That's your equation. We graphed it. Now, that's how you graph it. And remember, you need 2 things to graph the equation. 2 things to graph an equation. A linear equation. First is the slope, which is denoted by m. Second is the y-intercept, which is denoted by b. Okay, great. Now let's move on to the next thing. I'll want to go over correlations and best fit for linear equations on a graph. So there are 2 types of correlations, as you guys have learned in your high school math classes. The first one is a positive correlation. So something going up, something increasing, while something else is increasing. Second one will be a negative one. A third one would be no correlation at all. So this is a positive correlation. This is a negative correlation. This is zero correlation, no correlation at all. What correlation means is as your one object or your one item or your one thing is increasing or decreasing, what is the other word doing? If your one thing is increasing, if your x-axis is increasing, if your y also increasing, if your x is decreasing, if your y also decreasing, and if your x is increasing and y is decreasing, then that's an opposite correlation, which would be a negative correlation. Let's say you have certain amount of apples in your house, you have a lot of people. So a lot of people are going to be eating those apples. So you're going to be bringing more and more apples, and people are going to be eating. So the more apples you bring, the more people you have. The more apples you bring, the more people you have. The more apples to eat, and the correlation goes down. So that was that, and let's move on to a new concept. I will be moving on to writing equations of a line from a table. So the steps I'm going to be going over first are the steps. There are essentially two major steps that you need. The first one would be to first find the slope using a system of equations. Okay, find the slope using a system of equations. Second one would be then using the m, which we have found in the previous step, which is the slope, find b. Using the m, find b. And the third would be to write the equation in y-intercept form. So we're going to go over an example of that. Let's see, we have a table. Okay, this is a table that we have. We're given the x and the y values, and we are asked to graph and find the equation from the given values in the table. So let's see, we had, let me just write down the coordinates. We had 3 coordinates. We have 14, 14. We had 21, 10.5. We have 28, 7. Now we have these coordinates. So I mean, what comes to you? What comes to your mind first? What are we going to do first? Are we going to find the slope? We can do that because that's easy because we only need two y values and two x values to find the slope. So let's first start with that, find the slope. But first, let's just write what we're looking for. We're looking something like this, and what we're looking for specifically is the m and the b. So let's find the slope. We're going to be using two coordinates. Let's pick this one and this one. So we know the slope formula, y2 minus y1, x2 minus x1. 14, 21 minus 14, what you get is negative 4.5, and you get 7. That's what you get for your slope. M equals negative 4.5 and 7. One more thing that you will be doing, if you would like to change this to a decimal, you can do that. If you want to keep it in a fraction, you can do that. But you would you would not be able to graph this as easily with hand as you will be with a graphing calculator, which I am assuming all of you have, which and you can utilize as well when you're taking your exam. But just for the sake, I did it in decimal and I received this answer. Negative 0.6428 is the slope of the graph we're looking for. That's our M. 6428. Okay. Now next thing we're gonna be doing is looking for the B, which is the y-intercept. So next, what can we do now? Now we know the slope and we have a coordinate. So let's see. We can plug in the y and the x value. We can plug in the m. We are left with to solve with b, and then the y we have to change it to 0 because remember in the beginning I said in order to find the y-intercept we have to change the x to 0. Sorry. So let's put in negative 0.06428 x plus b. Let's use 1414 because it's easier for plugging in. And let's plug in. Now we have this, and remember we need to change. We specifically need to change this to 0, okay, to get the b. So we change it to 0. What are we left with? B. B is 14. So the y-intercept is 14. Okay. Now we can rewrite our equation in slope and step form. Y equals negative 6428 x plus 14.